Hello there and welcome to the October 2020 paper 2. Here we're looking at question 15. A geometric series has a common ratio r and the first term a. Given that r does not equal 1 and a does not equal 0, prove that this formula here is true. Okay, so let's first write down what a geometric series is. It's a plus a times r plus a times r squared plus a times r cubed all the way up to the nth term, which is actually a times n minus, a times r times to the power of n minus 1. Now what we do in this proof here is we multiply the whole equation by r. So it's going to be ar plus ar squared plus ar cubed plus ar to the power of 4 plus dot 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 plus ar to the power of n. And now what we do is we call the first line equation 1 and the second line equation 2, and we do 2 take away 1. Now what will that give us? Well, on the left hand side it will give us rsn minus sn, the sum of the first n numbers in the geometric sequence. But in this subtraction a lot is going to cancel out. This will cancel out with this subtract this will cancel out, this subtract this will cancel out, this subtract this will cancel out, and this will cancel out with the previous one there. So actually it's just ar to the power of n minus a. Now what we'll do is we'll factorize out the left hand side. R minus 1 equals ar to the power of n minus a. And we could actually factorize the right hand side as well, can we? ar to the n ar to the n minus 1. Divide by the r minus 1 and we get Sn equals a bracket Rn minus 1 over r minus 1. Well, that's one way of writing it, but if we times top and bottom by minus 1, that will give us the expression that we're looking to find here, which is 1 minus r to the power of n over 1 minus r. And there we are, that's the answer for this question here. This is a very standard proof question. Please make sure you've remembered this and remembered the same for the arithmetic sequence one. It's an easy 4 marks if you do get this in an exam. Let's move on to part B now. Given also that S10 is 4 times S5, find the exact value of R. So what we can say here is that when n equals 5, S5 is equal to a bracket 1 minus r to the power of 5 over 1 minus r. And when n equals 10, S10 is equal to a bracket 1 minus r to the 10 over 1 minus r. Now given that S10 is 4 times bigger than this one here, what we can say is that a bracket 1 minus r to the power of 10 over 1 minus r, the S10 one, is equal to 4 times the S5 one, a bracket 1 minus r to the power of 5 over 1 minus r. Now what we can do immediately is cancel out the 1 minus r's and cancel out the a's to leave us with 1 minus r to the power of 10 equals 4 minus 4 r to the power of 5. Now what we're probably going to get here is a quadratic but with r to the power of 5. So let's make a 0 on this side. R to the power of 10 minus 4r to the power of 5 and then plus 3. So therefore, if we now factorize this like we would a quadratic, but with r to the power of 5 as our power, then r to the power of 5 is either equal to minus 3 or minus 1. Because that would expand correctly. So therefore, r to the power of 5 equals 3, in which case r is the 5th root of 3, or r is the 5th root of 1, but r cannot equal 1, so there is no solution here. Okay, so there we are. So the answer to this question here, find the value of r, is the 5th root of 3. So there we are. That's the answer for question 15 there. So that's 8 marks in total. Let's move on to the final question of the paper, question 16.